The broadcast is now starting. All attendees are in listen-only mode.
All right. Good afternoon, everyone, and welcome to another great edition of the Skillshare webinar series put on by the National Center for Pavement Preservation. My name is Rob Green, and I'm with the Michigan Department of Transportation. I will be your host this afternoon. With me today is our good friend, Phil Rufus from Missouri DOT. He will be helping me moderate this session. Before we get started, just a quick reminder, as for many of you who have attended our webinars before, you know that our webinars rely heavily upon you as the attendees to make these webinars a success. So please, I encourage you as you're listening to the different presentations, if a question pops into your head, go ahead, use the chat pod that's over on the side taskbar, put your questions in as you come up with them. Once we get to the open discussion part of the webinar, myself and Phil will definitely get through the questions and they will be asked. Questions that we may not get to, we will write those down and we will follow up with the panelists for you and get back with you on those. So I wanted to share that. Secondly, PDH certification is also available at the end of our webinar as well, as the slide there shows. So for today's topic, for those of us who have PCC pavements, great pavements, but it always comes down to how do we preserve these investments that we have made. They can be very costly, but pavement preservation, concrete preservation, when done properly and early in the life cycle, can be done effectively. So today we've got a great panel for you that is going to walk us through some of the highlights, the overview of, and for today's discussion, we're going to be focusing on diamond grinding and grooving. So we've got John Roberts from IGGA, who's going to kind of give us that overview of the process, how it was developed, where it's going. Then we've got Christian from New York DOT, who's going to share with us some of the things that we want to look out for prep work for our projects. Then we've got Phil Clements from South Dakota DOT that will share some of the things to look out for in regards to warping and curling. And then we'll kind of close things out with Andre from Caltrans as we look at the next generation of diamond grinding and grooving. So with that, I want to say thank you to everyone again for logging in and attending. Please use the question pod as you start to hear things, if you've got questions that pop into your head. With that, I will turn it over to Phil to introduce our first speaker.
Thank you, Rob. On behalf of MoDOT as well, we're excited that you're all here to help us learn and understand a little bit more about concrete preservation. As Rob said, and I echo, here in Missouri, especially in St. Louis's Metro District, I have quite a few pieces of concrete, more composite than anything else, that are getting up there in age. So I'm extremely excited that we're able to bring this to you on some methods that we can even employ here at MoDOT to help keep those pavements going in fair condition, perhaps even in good condition as we move on. So our first speaker, as he said earlier, we're going to go from top down and then talk about stories. Our first speaker is, John Roberts. John Roberts is currently the Executive Director of the International Grooving and Grinding Association, has been so since 1999, and I'm extremely excited he's here to bring us that overview of the toolboxes that we can learn. John, go ahead and take it away.
Thanks, and thanks to everyone for the opportunity to be here with you today. Again, I'm John Roberts, Director of IGGA, and I also work with the American Concrete Pavement Association, representing their Pavement Preservation Partnership. So basically, my organization is the service department for the concrete pavement world. Today, I'd like to talk to you just a little bit about decisions and sort of how, as we get older, we get more and more decisions that have to be made, and they're more and more complicated. And certainly, that's an issue for us that work within the transportation industry. Things have changed a little bit. There's minimal system expansion now. We're asked to maintain the present system. In addition to that, while we're doing that, we're asked to minimize traffic disruptions, increase safety, make sure the customers are happy, give them a smooth road, a quiet road. And all the while, we're doing this with inadequate funding. And oh, by the way, yeah, let's protect the environment, which of course is quite important to all of us, I'm sure. So many transportation departments are turning towards the pavement preservation philosophy, which is simply put, keeping good condition. And lucky for all of us, there is a robust toolbox full of tools that allow us to preserve our concrete pavement. And I'll just touch on them briefly before we dive into the grinding and grooving. There's pavement subsurface rehabilitation used for subgrade repair. There's cross stitching, which we use for longitudinal cracks that are in good condition. Note, not appropriate for transverse cracks. More on that later. Partial depth repair used on surface defects and joint spalls. Full depth repair we're all familiar with, removal and replacement of concrete, full depth. And dowel bar retrofit, the placement of dowels across transverse joints or cracks of existing pavements used to limit future fall. And then there's joint and crack resealing, which minimizes water and incompressibles entering into the pavement system. Increasingly, we see specifiers using diamond saw cut surfaces to reduce roughness, noise, increase the friction, extend the life of their pavements, bridges, tunnels, and runways. And there's a number of reasons for that. It's economical, long-lasting, effective, and environmentally friendly. Think about it, whenever we're using any diamond saw cut surface texture, we're not requiring any additional aggregate or materials coming from nature other than fuel. What we're looking to do is just simply refinish the top, make it functional, make it smooth, make it last long. There's three diamond saw cut surface textures that we tend to talk about. Diamond grinding being the first, which is a process that ends up leaving a texture that looks almost like a corduroy fabric. It not only smooths out the pavement, but provides us with a low noise surface and increased macro texture, making it a very safe surface when used on a good quality aggregate. And then there's the next generation concrete surface, which we really won't touch on here today in my presentation, but you will hear more about that later in the program. Next up is safety grooving. And if you look at the picture in the bottom left, you can see that the blades are spaced further apart, 3/4 inches on center. And this process here is focused on increasing the amount of macro texture that you have on your surface. It doesn't impact the noise signal at all, and it doesn't impact smoothness, but it does make for a much safer pavement, and we'll touch on that fully in a few minutes. This cross-section will give you a slightly better idea of what we're dealing with. If you look at the top picture, that's a cross-section of diamond grinding. And the little channels are created with blades that are about 125 thousandths wide, 1/8 inch. And we space them, depending upon the aggregate hardness, to where we'll end up with maybe an 80 thousandths inch in a hard aggregate land area and 110 thousandths in a softer aggregate. And the concrete breaks off on a level surface, and hence we get the smooth texture, and again, the low noise signature and increased macro texture, providing us with a safer roadway. If we look at the bottom of the cutout, we'll see diamond grooving. And again, you can see the 3/4 inch centers, the same blade, 125 thousandths about, but we're not impacting the land area, thereby not impacting the overall smoothness or the noise signature of the pavement. And then there's the next generation concrete surface, which again is a topic you'll hear a little more about later in the program. And it's basically a hybrid combination of diamond grinding and safety grooving. So there's a lot of advantages to saw cut textures. The costs are competitive and really stable over time. The price has not increased greatly over decades. It enhances smoothness, surface friction, and safety, and noise signature, all in the same pass. So whether you're looking for smoothness or you're looking for friction, you're getting them both. It can be accomplished during off-peak hours with short lane closures. And texturing of one lane does not necessarily require grinding of the adjacent lane. So you can take those scarce dollars that you have and focus them in the areas that really require the attention. The saw cut surface textures don't affect the overall overhead clearances under bridges or signs or tunnels, and it allows you to blend patching and other surface irregularities into a consistent, smooth surface. And as mentioned just a minute or two ago, it's environmentally friendly and sustainable. We're not ripping it out, we're not tearing it out, we're not putting something on top. We're simply going to refinish what we have in place. So what is diamond grinding? It's the removal of a thin surface layer of concrete using closely spaced diamond saw blades. It results in a smooth, level pavement surface and ends up with a longitudinal texture with desirable friction and low noise characteristics. There's a number of problems that can be addressed using the diamond grinding process. The first and foremost that really drove the growth of the diamond grinding process was faulting at joints and cracks. And if you look at the picture in the upper right, you can see what appears to be around a 5/8 inch, 3/4 inch fault at a transverse joint. But if you look at the second picture down below it, you can see with a single pass of the diamond grinder, you can remove that fault and thereby reducing the rough ride and reducing the dynamic loading that in fact will beat that pavement to death and give it a much shorter lifespan. You can also grind out a built-in construction roughness, or you can increase the macro texture of polished surfaces. You can remove wheel path rutting. You can address curling and warping, and again, unacceptable noise level. Now here's an example of a 40-plus-year-old pavement in the great state of Wisconsin. It's US 45 in West Bend. It's, as mentioned, over 40 years old. And it's a jointed plain concrete pavement built without dowels. So the designers at the time had decided that they would use aggregate interlock at the transverse joints to transfer load from one panel to the next. But in time, over the decades, the aggregates have worn and those transverse joints have loosened up, and now they have experienced faulting. Full disclosure, I'm the cameraman on this video. I did 2 days worth of video on it. Take a look and take a listen if you can hear, and you'll see what the unground section sounds like and feels like. Okay, so there you have the unground section. Now, this is the day later after it's been ground. Same driver, same car, same cameraman, same camera. Now you can imagine the delight of the people that commute on this road on a daily basis and the reduction in damage that is being done to this pavement. And I'm certain that the DOT is increased the lifespan 10, 15 years on this pavement. Again, a great example. So looking at diamond grinding at large, you can provide a 50 to 70% improvement over the pre-grind profile with just grinding, no patching, no other treatments. Here's an example in Texas. It's I-635 in Dallas. And on the vertical axis, you can see the average IRI. On the horizontal axis, that's running down the road. The red line indicates the roughness, and you can see that in areas, this pavement was up to 225 inches per mile roughness, just about enough to make your teeth bleed. There was an average roughness of 150 and change. After a single pass of diamond grinding, lane width, full lane width, you can see that they reduced the IRI down to an average of 61 inches per mile. That's about a 61% decrease in the amount of roughness on this pavement without any patching, without any other treatment, simply diamond grinding. Looking at it from a network perspective, the Kentucky Transportation Cabinet did a real nice job. Over a 5-year period, they employed diamond grinding to reduce the IRI of their interstate concrete pavement. And over that 5 years, they went from 112 inches per mile down to 74.5 in that 5-year period. Again, that's about a 33% decrease in the roughness of their pavement, again, giving back to the driving public and giving back to the pavement itself by reducing the amount of dynamic loading taking place on that section or those sections of concrete. We can also increase the friction of the surface if it's polished. On the left, you can see a sand patch test on an unground section. And on the right side of the slide, you can see that same volume of sand spread across that surface, again, showing you a super increase in the amount of macro texture due to the diamond grinding. Further, if you look at some of the reports we have on our website, Wisconsin DOT and the Marquette University found that overall accident rates for ground surfaces were 40% less than for unground surfaces over a 6-year research period, 57% in wet weather conditions. And then there's the noise benefit that you get. While you're getting a smoother pavement and a safer pavement, you're also getting a quieter pavement. Research conducted by the National Concrete Pavement Technology Center shows that diamond grinding is the most quiet concrete surface texture commonly used. There is a disclaimer here. This data was put together before the widespread use of the next generation concrete surface, which is now the king of quiet concrete pavement, and it's a few decibels quieter than a standard conventional diamond ground surface, as shown in the graph on the right. So let's take the last minute or two here and talk about safety grooving. Grooving really gained traction, if you'll pardon the pun, when it was brought to Langley Research Center to evaluate several test groove patterns for runways. And at that time, NASA became somewhat curious and began doing runway grooving research themselves in 1962. Shortly thereafter, Caltrans began using safety grooving in 1963 for wet pavement accident reduction. And then concurrently, they had a research grooving project over a 4-year period that included 322 lane miles of grooved pavement and 750 lane miles of ungrooved control sections on concrete pavement. Now, I know you can't see the text here, so I've blown up the most important part. At the end of this research effort, here are some of the findings. They had a 20% reduction in total accidents, a 50% reduction in fatal accidents, and a 70% reduction in wet pavement accidents. And all the while, there were no issues with motorcycles or light vehicles impacted by this groove surface. And again, I'll repeat it, 20% reduction in total accidents, 50% reduction in fatal accidents, and a 70% reduction in wet pavement accidents, all from a simple groove. And this best tells the story right here. If you look at the right side of this graphic, which was put together by the Kansas Department of Transportation, let me back up a second. Friction testing in most states in the United States is done with a lock wheel skid trailer. And it can use one of two types of tires. One is a rib tire, the other is a smooth tire. The rib tire best simulates dry pavement conditions when you're testing the amount of skid resistance you have. The blue, indicated on this slide, that is a smooth tire, and that best represents the characteristics you would find in wet weather conditions. So if you look at the right side bars, you'll see that's before longitudinal grooving. Focus in on the smooth tire, the wet pavement characteristics. You can see we're around a friction number of about 20, give or take. Now, if you go to the left side of that graphic and look, you'll see that's after longitudinally grooving that very same surface down the road just a little bit. You can see that the friction number has doubled, more than doubled, over 40 on both eastbound and westbound. So again, the longitudinal grooving is tremendously successful in reducing accidents due to the increased macrotexture that you get from applying this surface. So in conclusion, diamond saw cut surfaces can provide you a lot of benefits. They'll enhance smoothness, surface friction, and safety. It can be accomplished during off-peak hours and closures. Texturing of one lane doesn't require work on the adjacent lanes necessarily. Doesn't affect overhead clearances. It blends patching and surface irregularities smooth. The longitudinal grooving has been shown to reduce wet pavement accidents up to 70%. Grooving does not create a hazardous riding condition for motorcycles and lighter vehicles. And grooving and grinding are inexpensive, long-lasting, and environmentally friendly. So it covered a lot of ground there in a very short period of time. I know we have some good time set aside for questions at the end of our program here today, but if there's something that you'd like to dig in deeper, you can always find us at www.igga.net. And I thank you very much for your attention today. Thanks.
Thanks, John. So as he also just brought up what I want to bring up, thank you, Peter and Ashok, for answering or asking some questions. I see a couple in the polls. There was a lot to digest there. So as you listen to our remaining speakers, go ahead and throw me some more questions and I'll have them sorted out to ask John or any of the other presenters at the end of the presentation. Our next friend Christian Olmoz comes to us from the great state of New York on the Materials Bureau, if I'm not mistaken, New York DOT. Christian's focus has been his state's concrete paving program. He's overseen numerous concrete pavement rehabilitation projects, and I believe he has been well placed to help us understand these projects, how they go, and perhaps some things to look for. Christian, you have the floor.
Thanks, Phil. So yeah, I work in the New York State Department of Transportation in the Office of Tech Services. I get to run the department's concrete pavement program, which is a whole lot of fun. So today what I'm going to go through is just discuss how once we do actually select a concrete pavement rehabilitation project, some of the things that we'll look at to determine if we're going to include diamond grinding or not include diamond grinding on the project. Another thing I'll get into a little bit is the repairs that we perform prior to diamond grinding the pavement, and then briefly mention our specifications for grinding and our desired outcomes for these projects. So getting into candidate selection, almost all the time we actually do include diamond grinding on our projects. On the right here, there is spalling that's caused by shallow mesh in an older jointed reinforced concrete pavement. On this particular project, this was isolated to a couple spots, but if this is a prolific issue throughout the project, we might look at an alternate treatment from a conventional concrete pavement rehab. The other thing that we've seen in the past is cases where wire mesh is shallow, but it's not actively causing surface spalling. In those cases, we'll still advance it as a CPR project frequently, but we'll often omit the diamond grinding to not take any more cover off of that mesh and cause further issues in the future. The other thing we'll look at is our drainage profiles, cross slopes, all of that. As long as we're not altering any of that, we'll include the diamond grinding. But if we have a project with a lot of drainage structures, utilities in the roadway, we'll also omit the grind and just go over to like a bump grind to address the repair areas to feather those in, but not do a full production grind on that project. I think the most important thing with including diamond grinding is just to understand the limits of it. Major surface distortions such as major faulting, major undulations in the pavement, those will not be completely taken out, even with a deep grind. We always try to just address these with our internal design groups when we're pushing these projects forward so that they are all aware of what they're actually getting out of this. Because diamond grinding, it's another treatment and it's not the end all be all of everything. So here's an example though of a deep grind that we did at a pressure relief joint where quite a bit had to actually be taken off to bring that level with the pavement. For isolated area, we're good with these deeper grinds, but if we're going to be removing a lot from the pavement structure across the whole project, we would look at alternate treatments rather than taking inches off of the pavement itself. One last thing I do want to mention too is for us with new construction, a lot of our projects are very short projects where we anticipate a lot of handwork. And on those also we'll include the diamond grinding, just smooth everything out to the same plane since handwork doesn't really have the same smoothness as a machine placed pavement. So now I want to just get into some of the repairs that we'll address before we actually perform our diamond grind. The biggest thing that we're trying to do with these diamond grind projects is improve the ride quality of these pavements and get that to last for as long as we can get it. So if there's major spalling, shattered slabs, faulting, those will continue to impact the ride of the pavement after the grinding is performed. And also any cracks or anything, they may fault in time, which will also impact the ride long term. So we all want to address all of those. So for full depth repairs, there's a couple things that we will always replace. Panels that have significant spalling, either from shallow mesh or spalled joints. Slabs that are shattered, like shown in the picture here. These are often the result of poor support, and we want to just make sure that we address that underlying issue before we go ahead and do the grind. The other thing is moderate to major mid-panel cracks. Minor mid-panel cracks we will address through dowel bar retrofits, but major cracks we will always do a full depth repair at to make sure that those don't move in the future and cause additional roughness in that pavement. So if we have an area where we have major shattered slabs, major faulting, anything like that, we want to always get into what the underlying cause of that is. And if we can address that economically, we will undercut and then replace that with sound sub-base materials. And that just solves the issue of recurring repairs at that location. So once we do perform our removal, we will always reestablish our transverse joints. And this also helps to prevent faulting at that transverse joint face. Most of the time, what we'll do is we'll place 4 dowels in each of our wheel paths, unless we're in a spot where traffic is crossing the lawn, changing lanes frequently. In that case, we'll increase the number of dowels to just make sure that we have full coverage across the lane. Additionally, for longitudinal joints, particularly, a lot of that decision making comes down to pavement age. A lot of our newer pavements built in the last like 35 or so years, we will reestablish that longitudinal joint using joint ties. But we also have a lot of 70-plus-year-old pavements where it just doesn't make sense with where they're at in their service lives to reestablish that longitudinal joint. So we will often omit the ties in those pavements. So moving past full depth repairs, the other repair type in our toolbox before we do perform this grind would be our partial depth repairs. So these are appropriate for smaller spalls. What we find is that mastic in particular works really well at our pavement joints. The one thing that we have had issue with the mastic is that when we do grind through that, if the repair gets too large, the head can kind of sink and pull at that mastic a little bit. So for that, we try and limit our repair sizes so that the machine head is not fully rested on the mastic at any point while it's going through the pavement. So a couple things with performing our partial depth repairs that we always try and address is if we're using a cementitious material, not allowing that to enter our joint or a crack. The photo on the right here shows a repair that failed from entering the joint basically and failing in compression. It's kind of one of those things that's, you get done with the project, you finish your grind and everything, and now you're going back out there and throwing cold patch on. Nobody wants to be doing that. So addressing that early on in the project and making sure that if those materials are used, that they are appropriately used. The other thing that is worth noting too is just knowing the limits of your partial depth repair. If you're getting into a situation like on the left here, where you have dowels that are coming out of the pavement, etc., you're going full depth in that pavement, you want to really revert that to a full depth repair. Again, because you just don't want to have this temporary fix that gets you a couple months and you're out patching it again. So next thing is just addressing minor cracks. So we'll use dowel bar retrofits at a lot of those because it's not necessary to go through and perform a full depth repair all the time at those. The dowel bar retrofit works great for minor cracks where you have good aggregate interlock still, but there's just not that joint steel. And this will really help with long-term with the rideability of these pavements with preventing the joint from faulting again. And then same thing with our longitudinal cracks. If we have a crack that's tight longitudinally, it has good aggregate interlock still across it, we'll often employ the cross stitch technique to just hold that crack together, keep it from opening up, and keep it from settling across that crack over time. The last thing I do want to mention is joint resealing. So this is another thing that we typically will perform on our projects. It's important that this is done after the grinding is done. So when we go through, we do our diamond grinding, we require 95% of that pavement surface be surface ground. So when they're going across joints, a lot of times the head will catch the joint sealant material, pull it up, move it around, and it won't be an effective seal anymore. So we want to do that reseal after the grinding is performed so that we actually have effective sealant in our pavements. The last thing is I just want to touch on our expectations, I guess, for our rehabilitation projects. So we operate our diamond grinding as a percent improvement spec. So we'll profile the pavement before any repair work is performed, and then again after the grinding is completed. We'll then compare the results of those two. We're expecting that we at least see 50% improvement. If we're seeing anything over 55% improvement on the ride for that project, then we'll actually get into this incentive adjustment for that ride quality item. So that's all I have today, but thank you guys for listening.
Thank you, Christian. So we've heard from New York. Let's go west. Let's go to the middle of the country. My next presenter is going to be Phil Clements. Phil Clements is South Dakota's pavement engineer, and he's responsible for the state's intensive network of roads. Phil's also the current chairman of our Midwest Pavement Preservation Partnership, by the way. And I believe he can offer insights from his over a quarter of century of service and experience. Phil? You might be muted.
Much. Good afternoon, everybody, and welcome to this webinar, and thank you for having me on this presentation. Hang on just a second here. Okay, so Rob told us when we were going into this webinar to talk about the good, the bad, and the ugly. And let us kind of take this in order. We're going to look at some of the stats on PCC pavements across the state of South Dakota, what South Dakota DOT has in its toolbox for large-scale PCC preservation projects. And then the bad and the ugly, we're going to talk about the story of issues with warping and curling and some of the lessons that we're wrestling with this beast and how we are kind of moving forward from this. So statewide stats on state maintained PCC highways in South Dakota, there are 1,880 miles of a total of 8,845 miles of two-way miles of PCC on the entire state system. For the interstate system, we have 869 of 1,358 two-way miles of PCC, which is about 64% of that particular system. PCC preservation treatments are considered in the state's pavement management system. These include 3 distinct treatments, all applied as either standalone or in combination with each other. And that is the joint and spall repair, which can include, we usually classify that into 2 separate classifications, which would be the minor or major joint and spall repair. Minor is anywhere we have less than 40% of full depth repairs, or a major is greater than 40% of full depth repairs in combination with partial depth repairs for the joint spalls. We also do diamond grinding, and with that, part of the diamond grinding prep is a binder joint and spall repair. Of course, after grinding, you usually do a sawing and sealing of joints with that. So we have, over the years, had great success with these treatments until we encountered on I-90 the stretch from White Lake to Mitchell, South Dakota. So the PCC between White Lake and Mitchell, South Dakota was built between 2009 and 2013. Much of it was built in a hurry in the ARRA, or the economic stimulus era. Shortly after this done, we received a call from someone out of our research office, And he was riding in a 1-ton utility truck and was getting bounced and rattled so much that it was spilling his coffee. Lesson 1 is never spill a researcher's coffee. Lesson 2 is that we had discovered that warping and curling had developed. This was kind of a nightmare. This would be most noticeable for certain wheelbases, such as trucks and trailers, such as pickup trucks pulling boat trailers, among other configurations. But then you would get into where if you were driving a normal passenger car, you could hardly feel it. So it was almost like a sympathetic vibration. And what happened to develop this warping and curling? So basically, jointed PCC pavements are constantly moving and changing their shape during and after construction. And you get into the science of it, the exothermic reaction of cement hydration expands the volume of the concrete, right? So as cooling occurs, the slabs decrease in volume. Now, with environmental conditions, if they're just right, the using of cures, if they're not used just right to minimize evaporation, and then you look at reflected the sun with the cures, dictate if curling or warping settles in or not. And in the case here, it appeared that either, well, we're not sure what the cause was, if it was the cures, if it was a wet season that we had that particular year when we were building it, but things did not go right. So the warping and curling is magnified or lessened by temperature changes during the day. Not only that, as the concrete ages and the slabs shrink, the curling will become even more exaggerated. This presents some pretty significant problems when you try to grind this pavement. An attempt was made by putting together an informal research project back in 2017, where many test profile runs were done at varying parts of the day. The specs you see in front of you are the results of this research. Contractors and project engineers were not very happy with the specs for this for this treatment. As you can see, PCC pavement was not to be performed between the dates of June 10th to September 15th, which was basically the peak of your construction season, right? And then grinding also would not be performed between the hours of grinding will only be performed between the hours of midnight to 10 a.m. So this is so that you could capture the time when the slabs were curled the most. So, yeah, so this caused grinding projects, the mobilization costs to be driven up. And as I said before, contractors and even DOT personnel were not very happy with that spec. So State Research Project SD 2022-07 is a formal research project that was opened to follow up with the V1 or version 1 of this project. We wanted to see if the specs made much difference from the first version and what we could change. Detection of warping and curling in the profile data is also important in being able to properly model and perhaps add treatments or the triggering of treatments to the pavement management system so that we can properly program grinding treatments before they become too rough. Perhaps there is another treatment out there besides grinding, or maybe another version of grinding. That's kind of what we're trying to find out. Tentatively, the results of this research are to be tested in a project in fiscal year 2026. This also has implications with our new designs for other PCC pavements as well as a preventive maintenance. Kind of goes without saying, and not pointing any fingers at any contractors or consultants or anything like that, but what it comes down to with this particular problem, if it had been built correctly in the first place, we probably would not have seen this issue. So with that being said, that is all I have. It is hoped that our research project with NCE will yield a favorable treatment spec for this issue. I thank you. My contact information is here. And Phil, I turn it back to you.
Thanks, Bill. So, yeah, I enjoy the good, bad, the ugly too. For once, it's not coming from MoDOT. So thanks, South Dakota. We learn a lot through decisions and we've made in the past. And I think that's, again, as Rob said in the beginning, one thing that's different about this webinar, we teach you things we tried and what they worked, they didn't work. But that curling thing, I think I have a problem on I-64 here in town. And I bet you it's because it was due to the weather. So let's go and let's fly this knowledge jet and land it on the West Coast. Our last speaker before we take all of your questions, and by the way, they are coming in hot and heavy, thank you, will be Andre Totari from Caltrans. Andre is currently Caltrans' senior transportation engineer in their Office of Concrete, and I know he's got quite a bit to say, so why don't you go ahead and take it away, Andre.
Thank you, Phil. Good morning, everybody. As Phil mentioned, my name is Andre Totari. I work in the Office of Concrete Pavement over at Caltrans. And I am going to be wrapping up today's panel discussion with a conversation about next generation concrete surface with a focus on its applications in California. We've already kind of discussed the fundamentals of diamond grind and diamond grooving. And as we will see in this presentation, NGCS combines the benefits of diamond grind and diamond groove and builds on those techniques, pushing them forward to meet the demands of modern pavement design. So real quickly, just to go over the topics of discussion for today, I'm going to start off by defining what next generation concrete surfacing is. I'll go over how it's constructed and the specifics on the order. And then I will go into the pilot project that kind of got it all started in California, and then focus a discussion on the results of that pilot projects and what those results meant for us. And lastly, I'll talk about the current status and our future goals here at Caltrans. So NGCS, what is it? NGCS stands for Next Generation Concrete Surfaces. It was developed by the International Grooving and Grinding Association, along with the American Concrete Pavement Association and Purdue University. And it is a specifically engineered texturing technique, grinding and diamond grooving in a specific order, in a specific manner, as we'll see later. And it was developed to reduce tire to pavement noise, create smoother pavements, and increase durability. On most high volume, high speed roadways, noise emissions are predominantly caused by the interaction with the vehicle tires and the pavement surface. And these high level of noise can be irritating not only to the people in the vehicles, but the surrounding community. NGCS addresses that concern and kind of creates a much quieter concrete pavement for the traveling public and the community. So how is it constructed? Well, first you'll start with a diamond grind. Also, another way to say it is the flush grind. And this step is to remove any irregularities like bumping or faulting, as we discussed earlier, and creates a smooth flush surface for the following steps to climb. The next step would be surface cleaning. This step is very important as dust, dirt, oil, rubber, anything on the surface can clog the diamond grinding blades, and this can reduce the cutting efficiency and cause uneven grinding and grooving. A clean surface ensures that there's consistent contact of the blades and the surface of the pavement, and it maximizes the life of not only the grinding equipment, but ensures a uniform surface texture for the traveling public. Following the cleaning, you'll get into the diamond grooving portion of the construction. And as we've already discussed, diamond grooving creates these longitudinal grooves. For NGCS, they're typically about an 1/8 to a 1/4 inch deep, about maybe a 1/2 an inch apart. These aren't set in stone numbers, but on average, that is what we do here in California. And then last but not least is your quality control, quality assurance. And this is basically to meet the performance goals. You'll check things such as the groove depth and spacing, surface smoothness, skid resistance, and you ensure that the final product meets the specifications for your state and provides a quality product for the traveling public, which is important. So I just included a couple pictures here of some projects in California. This is one project where we did diamond grinding. As you can kind of see, the surface looks pretty flush. There's no irregularities. It looks almost smooth. And then diamond grooving, as you see on the picture of the right, that's the blades being dragged by the truck. And you could, if you look closely, see the grooves that are left behind those blades. The left picture is kind of is a finished product picture of what NGCS would look like. So moving into the pilot project. So the pilot project in California was constructed in 2011. It was on I-5 near Solana Beach, north of San Diego. And what they did here was they performed conventional diamond grind on about 10 miles of roadway in both directions, all lanes. And then they went through and performed NGCS on multiple different 1 mile long test sections. Again, both directions, all lanes. The pavement that they performed this NGCS on, their construction dates varied from 1960 to 2000. So basically what this means was the NGCS was performed on pavements that were anywhere from 10 to 50 years old, all structurally sound. A little more information, the average annual daily traffic was about just under 150,000 with approximately 5,600 trucks. And then data was collected before conventional diamond grind was performed, after conventional diamond grind, and then after the NGCS. And they evaluated the smoothness, noise level, and surface friction. Smoothness, because that directly contributes to the ride quality, improved fuel economy, reduced emissions, as well as so many other factors. Noise, as reduced noise was one of the primary goals of NGCS. And then surface friction, because that directly contributes to the driver's safety. So here are the results. The first column is your roughness factor. The second column is the noise levels, and the third and fourth columns are the friction levels. So starting off with roughness, you can see that the original pavement had an IRI of 158. After conventional diamond grind, that was reduced down to 60. And we already saw how conventional diamond grind does reduce roughness by approximately this amount. In this case, it was a 60% reduction. Now, NGCS specifically reduced that roughness by another 20 points, which led to a 76% overall reduction from the original pavement. And this number is comparable to high quality new pavement. So very great pavement. The next column is the noise levels measured in decibels. And at first glance, this may not seem significant. 105.2, 103.2, 100.7. That doesn't vary very significantly, but the thing to remember is that the decibel scale is logarithmic. So these numbers are misleading, okay? A 2 decibel reduction from the original pavement to the conventional diamond grind is actually a 37% reduction in noise level. And then to go further, the 4.5 decibel difference from 105.2 to 100.7 is about a 64% noise reduction level. And another way to look at it is 105.2 is about 2.8 times as intense as 100.7. It's not 2.8 times louder, but it's 2.8 times more intense. So very significant. And then lastly, unfortunately, they didn't take any smoothness or skid testing of the original pavement, but we do have numbers for the conventional diamond grind and NGCS. What we see here is conventional diamond grind produces a slightly higher skid number, but in both cases, the conventional diamond grind and the next generation concrete surface, they exceed the maximum or the minimum desired skid number for heavily traveled high-speed roadways. And although NGCS may have a slightly lower skid number, it still provides a safe surface for the traveling public. And that's the most important part. So what did this mean for California? Well, basically, the results were overall positive. We saw that NGCS had positive impacts on smoothness, noise, and surface friction. So currently, here in Caltrans, we have at least 9 projects that have implemented NGCS since the pilot. Now, this number is probably much larger, or I shouldn't say much larger, but larger for sure, because we don't have a database of projects that utilized NGCS. These 9 projects are projects that are known to me to have used NGCS. So again, it's probably a lot more than that. We're continuing to monitor noise sensitive areas with NGCS to see its effects, as well as researching on the weather and climate resilience of NGCS. So that's kind of what we're doing right now. Our future goals are to integrate NGCS into the Caltrans pavement strategies, as well as the Caltrans standard specifications, and put possible training programs together to get this information out to our districts, as well as anybody else who is interested. That's kind of all I had together. I did not put my contact information, which I should have. However, if anybody is interested, I can definitely provide that and we can share it with everybody in the end. With that, I'll go ahead and hand it back to Phil. Phil, you could take it away.
Thanks, Andre. That was awesome. One thing we're going to do a little different. Let's ask at the end of the presentation. I'd like to know who are we talking to? Could you please take about 15 seconds and answer this simple poll that I'm just kind of curious as we do these entering, oh crap, it's been quite a few years now, who we're actually reaching out to. So while you do that, I want to say thank you to Dr. Mirosohaney for putting that link to us that we posted to the field guide handbook for the maintenance and preservation treatments from INDOT. I hope you all see that in the chat. Thank you for providing that as well. I will definitely be reading that in the near future. So as I come close to 15 seconds, go ahead and let go, Andre. Okay, that's good to see. Okay, so I'm going to call all of our panelists to go ahead and turn the webcams back on. I've got quite a few questions. So if you would go ahead and put all your webcams on. And we have several topics that I'm going to try and put together on how many people asked the same question, what kind of things are similar. So people who asked, if I slightly alter your question, it's because 4 of you have asked probably the same question. Biggest topic, cost, money, dollars. On this one, the exact one is what's the cost per square yard of diamond grinding of concrete? I'm going to ask John to give me a national average, and then if you could, anybody else from the states. John, what is the national average? What does this treatment cost us to diamond grind concrete?
The answer is just a little bit broader than a hard number. Diamond grinding costs vary based on a couple different things. Number one, aggregate type. If you're in a soft limestone and you have a good sized project, 100,000 square yards, and you can grind all night, you may see a price under $2 per square yard. If you're down in Louisiana and you're in an aggregate that we call deadly black, because it's so hard that it's put a bunch of guys out of business, you might see $20 per square yard. And again, that's going to be based on your aggregate type, number of hours you can work, union conditions, and the like. On average, though, if you were to bring me and just say, give me a number for grinding across 100,000 square yards on an average aggregate, I'd say it's going to be about $3.50, $4 per square yard. Could be less with favorable conditions and non-union states.
Sweet. Coming from the West, Andre, you got a guess? You can always answer no. You've done at least 2 jobs I've seen on the web.
I do not have an actual number for that. I do know it's fairly cheaper than other preservation strategies, as you know, it doesn't require extra materials and things like that. But as far as an actual number, I will hand that off to somebody else.
South Dakota.
I don't have a square yard cost, but I do have a linear mile 2-lane, and the number 136,000 per mile, and that includes the grinding and the reseal of joints. It does not include mobilization or traffic control or anything like that.
Well, that's a good answer. New York? Christian? You may be muted. Well, let's circle back. Second question, I think we'll go back to Robert starting it because Ashok asks you directly. I will quote it. We are seeing gouging / gulling of concrete pavement surfaces as a result of diamond grinding operations, which creates a safety hazard for the motorists, particularly motorcycles. Would you comment on that, and have you seen that?
Bill, is that
So
one for me?
Yeah, Mr. Roberts. Sorry. Mr. Roberts, my apology. He said Robert. I apologize. John.
Yeah, okay, gotcha. And just to be clear, there's gouging taking place? Read that once more.
Yep, I'll read it right from you, from my friend Ashok. We are seeing gouging / gullies of the concrete pavement surface as a result of diamond grinding operations, which creates a safety hazards, particularly for the motorcycles. Would you please comment on that, and have you seen it, Mr. Roberts?
Yes, I can say I will comment on it, and I have seen it, and it's 2 words, operator error. That should not be the case. Diamond grinding is an abrasive process. It's very much like a belt sander, and it's not going to gouge, it's not going to cut, it's not going to break your aggregates. Basically, what we're using to grind are synthetic diamonds. Synthetic diamonds cannot withstand impact. Take one, hit it with a hammer, it's going to shatter. And being that they can't withstand impact, they can't deliver impact either. So gouging it's not like carbide. And I'm wondering if the question perhaps is more towards a carbide rotomill operation, because the only thing that would leave gouging or dips would be the operator on the machine not knowing what he's doing and not meeting specification for sure. That should not be the case.
So John, what we've seen, Ashok is one of my colleagues here in Michigan, and I know what we've seen here is some of the fins kind of get broken off in the pavement, and I think then that starts to create wider grooves in between. So like if you think about the diagram that you had up that kind of showed the blade spacing, that for whatever reason in some of our projects, and I can talk with the Ashok offline about this, but I think that's what he's referring to, is that sometimes some of those fins in between the blades ended up breaking off, and I think creating wider than specification on that.
Okay, so I would then call that a setup issue. in terms of blade spacing. You know, basically when we bring a machine out to a job site, you're going to look at the aggregate. Perhaps you'll do a petrographic on it, probably not, but you'll do a scratch test like Mohs hardness or something of the like, and then you'll determine what spacer you want between the blades. And if you set it up wrong, you can have a texture that doesn't meet spec or may be ugly or may do what you just said. So again, that would be a setup issue and a failure to stop and fix the issue before going down the road with the grinder.
Like I said, I'll follow up with the Shook just to confirm and circle back with you as well.
Great.
Sweet, good transition. Speaking of IRI, which you weren't, there's several questions regarding IRI, and I think I'm gonna give you a softball. First one, do you see any value in diamond grinding new pavement to achieve a desired IRI, or is that a practice that you would discourage? Let's start national and go down to state. Mr. Roberts?
There's a number of states that utilize diamond grinding as a final surface texture due to a couple reasons. One reason would be that a lot of the concrete pavements being built are in areas where there's a lot of stops and a lot of starts, a lot of phasing. So it's not like paving through a green field where you can set up at 8 o'clock in the morning and pave all day right up till dark. So there's typically roughness issues that are inherent in those types of projects, and the designers are in front of it and saying, we know we're going to have some smoothness issues. We're going to have an item in there, so it's not a bone of contention. There's other states that enjoy the fact that the quietest concrete surface you can have is a diamond ground surface. We see that in Florida, for instance, and they opt to spend the money on that to end up with a premium pavement. So certainly value to those that have issues that they want to overcome, no doubt.
My other friends, your states, they do it. MoDOT does. So, but I don't have a lot of experience in producing new concrete.
Here at Caltrans, we kind of discourage any preservation strategies to be done on new pavement, as preservation is supposed to be for older pavements. That being said, it's not like we've never not, or we have done it. Again, in certain situations where smoothness was a concern, we have done it. And then sometimes it's the concrete was done and it was not done in an appropriate manner, and we are having smoothness issues after the fact that weren't anticipated, and we will do that to correct the concrete. However, it is not something we usually include in a project's bid.
Okay. Christian, do I have you back yet? I think we might have had some technical difficulties earlier regarding New York. Yeah, I think I may have lost you, buddy. So if you can send me a quick text. I'm not hearing you. Well, let's then switch again. My apologies, but I'm going to ask you a simple one, I believe. But the question is from Peter. Does diamond grinding, forgive me, typically happen with special equipment, or can you put a diamond grind drum on a traditional milling machine? I'm gonna throw that as a softball.
That's coming to me.
Why not? You talk first.
I will. Traditionally, the vast majority of the diamond grinding units being employed around the world are specialty built machines made to only diamond grind. In recent months, I will say, there's a milling machine manufacturer that has introduced to the United States a bolt-on device which goes on the milling machine, a traditional milling machine, which they are at this point in time, I'll call it testing. There's a unit in California and a unit out east where they're looking to see if this is a feasible means of grinding and getting around buying a grinder. It's not mainstream. It doesn't meet most state specifications, but there's a couple states that are willing to take a look, and the jury's out, but I'm curious to see and excited to see what the outcome will be.
Anyone else? I think that's a pretty easy one. Phil, Charlie wants to know something. Regarding your warping and curling, have you found a way to detect this by a systematic ride data collection, as it's dependent on the wheelbase of a vehicle? Phil?
That is actually part of the research project that we're looking at. And in the past, when we were detecting it, we were able to use it or able to detect it using the quarter car method. If you know anything about profile, and then you actually have to look at the profile itself and see the undulations of the warping and the curling in the pavement. There was really nothing as far as filters or detection or anything at that time to really except looking at what the actual IRIs were. When they were going through the project to grind the first project and ground the pieces and looked at the IRIs after they did grind them, there was a reduction in IRI, but you could still see that undulating pattern in the pavement. So it kind of a tricky animal as far as how that reacts.
Okay.
Can you guys hear me on here?
Yes, Christian, good to hear your voice.
All right.
Now you caught me. Sorry, Christian, I have a question regarding, well, it's just a basic question, is do you have any empirical data showing that your cross stitching and slot stitching have a time that they, have an additional surface life added because you do them? I did not read that right, but I hope you got the question. You want to try again?
Yeah, so for the cross stitching, so we don't do a whole lot of slot stitching. We've had one project, but for the cross stitching, we do see an increase in service life compared to pavements that were not cross stitched, where we actually do see that crack basically open up over time, and then it becomes a full depth repair.
Could I pin you on a time? 5 years, 3 years? That's just for me.
Oh, I mean, once we've done these, we've had these in service for 20 plus years.
That's good.
In a lot of cases.
Okay, I'm glad to have you back. I have a few others, but I need to switch over, if I could, to a question I think that we haven't addressed yet. Disposal of slurry. How big a problem is that? I'm going to start with Mr. Roberts and go to the states if I could. How big of a problem is slurry disposals in various states? I assume this is very depending on county. Do the slurry need to be transported to a special dump? Can I start with Mr. Roberts?
Yes, sir. The easy answer is it depends.
Yeah.
It depends on where you're at and what the regulations are. There are some states that treat it like nuclear waste, and you have to separate the solids from the water and then go to a water treatment facility or a solid waste facility and so on, which almost makes it impossible to afford grinding at that point in time. The majority of the states around the country do allow for casting of the material into the shoulder as long as proper precautions are taking place around any kind of drainage inlets or bodies of water and so on and so forth. So that's still an approved method. If you look at the chemical analysis of a concrete slurry, it's very much like a 50% strength agricultural lime. And there's numbers and acronyms that are used within that to describe it that a farmer might understand. But at the end of the day, it's a weak lime mix. And we see states are okay in allowing that to be deposited in the median or the shoulder. We also see states that would allow that material to be used as agricultural lime. So if you can produce a farmer that's willing to take the material, that's a real farmer, that material can be transported off-site and deposited on farmers' fields and the like. But then there's other states where it's like, nah, no way. We need to be able to keep, this is state property. You can't take it off state property, so we need you to either do a pit and then try to find ecological use for the material like fill or soil stabilization, or they may have you go to a solid waste facility once the water evaporates off the top. So it really varies depending upon where you're at in the US as to whether the stuff is treated as a real danger or whether it's a beneficial use product.
Thanks, John. Under your nod, what do you got? Caltrans.
Like he said, it depends. We have two different disposal methods, on-site, off-site. So there are some projects where you are allowed to dispose of the slurry on-site. This will be identified in the project documents, so you'll know ahead of time. If it's off-site, it just needs to be a Cal EPA accepted facility. And that's pretty much all we do in Caltrans. It's not that complicated for us.
We let ours evaporate and then we put it in solid. Michigan, South Dakota, New York.
Yeah, so similar to Cal, to where when we're in rural sections, we can usually dispose of it right there on the shoulder. Once we get into more urban sections, the slurry needs to be collected and then disposed of properly. So
South Dakota too, and I think there's a little more special care when you're near waterways or when you're near wetlands. I think is another one, but other than that, really no special treatment.
Yeah, we're pretty much in the same camp as that. Rural areas, off onto the side of the road. More urbanized areas, we'll truck it off site and get rid of it.
All right, here's a softball, or maybe not. Would you ever consider diamond grinding a pavement that is 75 years old?
Yes.
Are there any special considerations? If yes, I don't know who to ask.
Depends on the condition.
Yeah.
Good answer.
You
That's
don't
good.
have a lot of
Good dodge.
spalling?
Good dodge. It's a cute question. I love questions like that. They're like,
I
yeah,
agree. It definitely depends on how structurally sound the pavement is. Like I said, for our NGCS pilot project, it was done on 50-year-old concrete pavement, and it was structurally sound and it worked perfectly. So it just depends on the status of the concrete pavement.
Yeah, I'd agree with that.
Just an aside, and this is a project that we had go awry. We had I think it was a 43-year-old pavement. Actually, two 43-year-old pavements. One on the west side of the state, one further to the east side of the state, done at the same time. The west side project had no issues. We ground it, performing beautifully. The east side one, however, something happened. We don't know if it was during initial construction or if it was something over the years, but we started seeing the center line come apart after the grinding was done. Now, we don't know if there was some sort of void in there, like I said, during construction or what, but might not be a bad idea to maybe core it before you grind it, just to make sure there isn't something hideous underneath that might cause some issues.
Christian, I cut you off. What were you saying? I'm sorry.
Oh, yeah, no, I think the oldest pavement I've actually seen ground here is 93, and still going strong, so.
Thank you. That's awesome. Well, they keep coming in, guys, so we're going to have to go just ask them as they come in. So starting with Caltrans for me, you show IRI improvements. Were those on JCPs or CRCP pavements?
That is a very good question. And honestly, I do not know. I would have to go back and look at the pilot project and exactly what they were.
Cool. Ours are all on JCP. We only have one CRCP pavement in my district. Phil, you got anything for me in South Dakota? Otherwise, I'm going back to New York.
I don't think we've done any grinding projects on CRC. Plenty on jointed, but not that I recall.
Okay, New York, you don't have any continuing reinforced concrete, do you?
Nope, no CRCPs here.
So I think that's your answer. Forgive me, Andy. I think that's your answer. Yeah, it's all JCP. Have any of the states, by the way, Andy, used this NGCS, or is it only Caltrans? Either I'm not talking or you can't hear me.
No. You didn't. Are you asking the panel? Are you asking like?
I'm just asking
John?
Amy because I got 2 questions here on the right. I'm shooting from the hip now. So, do any other states use NGCS or is it just Caltrans?
Oh, no, it's being used abroad. Oh, yeah.
I told you when I met you, I don't know a lot about concrete. You have me at a massive disadvantage. I'm saying the letter slowly, so you know I don't know what I'm talking about.
Yeah. It's
Go ahead, John.
It's been used north, south, east, west. You bet. It's a low noise solution now, and it's not experimental. It's mainstream. There's millions of square yards of NGCS in Texas.
Thank you. And
Yes,
now
sir.
you see the good, the bad, and the ugly from me. Let me try this one, and I'll just ask. Kansas asks, do any states have specification requirements other than quality to prevent diamond grinders from bouncing and creating shallow corrugations? And I don't know who to ask. John, you start doing that stuff.
I think that it sounds to me like that might be a surface that wouldn't meet spec.
Yeah.
I mean, that would be a shutdown right then. Like, what are you doing?
That's from KDOT, because I know who wrote that. I don't think we have one either. Yeah, once those start occurring, we're stopping it and something's not going right. It might be a little more of an upgrade. We don't have any specification requirements though, other than quality to prevent that.
Yeah, same at Caltrans. It's pretty much just quality. I mean, if you're diamond grinding and it's getting bouncy, I'm assuming the quality is going to be off, and there you go.
Speaking of IRI, which we weren't, would you, you know what, Christian, would you take this one?
Yeah.
Would you talk more about the percent improvement regarding new IRI versus old and how that applies in New York before and after?
Yeah.
Because the actual question asks, talk more about the percent improvement before and after. Christian, do you have anything on that?
So for our rehabilitation projects, those are all percent improvement. For new construction, we actually do require a IRI threshold of, I believe, less than 90 for when it's a handwork project, and then it's a less than 72 inches per mile for new construction when it's machine placed.
Cool. Okay. At one point, you don't have that one, sorry. We're not doing that. We all agree we don't have any concrete, continuous reinforced concrete. Are there any concerns from Spencer doing grinding on newer type, and I'm just going to say looks like IL mixes? We're starting to see more scaling and longevity issues we think are tied to the cement changes. Mr. Roberts, I know you know what that means. Go.
I do, yes, 1L cements, and that's the cement industry's valid attempt to try to reduce the carbon footprint in their powder. And there are some growing pains in the marketplace. There's a learning curve. I don't think that the entire industry has got their arms wrapped around it. We have not experienced anything untoward with regards to bump grinding. There's not, the 1L cements are not old enough to be in full rehab mode at this point in time, still pretty young stuff, but there are definitely undertones of people being dissatisfied with how it reacts. Just a quick example, a huge bridge project in Illinois, and one of the contractors that I work with was the sawing contractor. And the first night they went out there and the concrete wasn't going off. And they have a full crew out there waiting. And all of a sudden, the material, the concrete, just started to solidify so fast and started to crack down the line and got in front of them. And it was just like, what the heck happened here? The next night they went out there with an entire army and waited around forever, and they managed to stay on top of it. But my point here is it acts differently in some situations. And as far as grinding, no issues yet. But I know in terms of sawing, there has been some big time lawsuits that are underway at this point in time.
Thank you. Anyone else? Hearing none. I have 7 minutes left on my clock and I have 9 more questions. So again, I offer you guys a challenge. You all accepted it by inundating me with questions. I will get those answers to you. I have them here in the chat. You can't see me mouse over. But I want to finish with this last one because I haven't heard it asked yet. And I'm just going to quote it. I believe you've covered this, but you mentioned diamond grinding. How many times can you effectively diamond grind a pavement, or can you? And if you do in fact do more than once, do you see a decreasing rate of return? I want to go with John again because he seems to have a lot of good stuff to say today. John?
Yes, sir. Absolutely, you can grind a pavement multiple times. It depends on your thickness and so on. But as an example, I-10 in Southern California has been ground 5 times since 1964. And there's still large sections of exposed concrete carrying zillions of easels every day. Georgia, 3 times, 4 times. As long as you have the thickness, if you're just making that pavement smoother, the reduction in dynamic loading that you're creating by making it smoother makes up for the loss of a little section thickness. And again, whenever we're doing diamond grinding, unless it's a bad faulted pavement, you're probably only taking off 3/16 to a quarter on average. So multiple times, no problem.
Christian in New York, I know you're part of that rehabilitation. Have you rehabilitated diamond grind your roads more than once? Is that a common theme in New York?
Yes, yeah, a lot of the pavements down closer to the city have been done 2 or 3 times at this point and are getting ready for their next rehabilitation cycle.
Okay. Caltrans, you're nodding your head, and I see South Dakota as well. Okay, well, again, thanks for letting me run this with you. I'm going to go ahead and get back to you guys. I haven't got back to, but I'd like to turn it back over to Rob Breen for some final thoughts here at the end of our program. Rob?
Yes, thank you again. And thank you everyone again for showing up and bombarding us with the questions. It's fantastic. Like I said, this is how, in my opinion, I think this is why these webinars are such a success. I'd love to be able to have you all come off mic and actually have an open dialogue. This is the best we got. Phil does graciously track answers down, get back with some of you. Looking through the questions, I see a lot of them also regarding specifications. Once upon a time, and I was just feverishly looking on the website for the National Center of Pavement Preservation. If you go underneath the publication section, we do have, because there's a question regarding specifications. Once upon a time, we did have a lot more comprehensive list of preservation specifications. I know one of our task forces within the Midwest was debating on trying to revive that. It's just kind of hard to try to maintain that database as people are constantly updating their websites, so web links get broken, so on and so forth. But we can hunt down some specifications. John, I don't know, does IGGA have state DOT specifications on there, or?
No, the specifications change from sometimes district to district, and we found we used to have a database, and it was impossible to keep up with. What I will say though is we finally got approved after about a 3-year effort, a AASHTO approved diamond grinding spec based on percent improvement. So if you're looking for an AASHTO approved specification, one of those does exist.
Okay, and that was going to be my next comment, was maybe there's an AASHTO approved specification that people can use. So agencies that don't currently have this fix within their toolbox, we all know it starts with the specification. Spec writing can be a painful exercise, but if you have the AASHTO one to start from, that's always a big help, or borrowing from other states. Again, if there's something in particular that you're looking for, please feel free to reach out. The slide right now has everybody's contact information. Reach out to me, reach out to Phil. We'll be more than happy to help hunt some stuff down. But yeah, in closing, just want to say thank you again to everyone who attended. Thank you to our panelists. You guys did a fantastic job fielding the questions. I know sometimes maybe that's a little bit more nerve-wracking than the presentation itself, because you don't know what type of questions are going to be coming your way, but you all did a fantastic job. So thank you. I look forward to our next one. We try to run these quarterly, but I think that starts to get us into the holidays, so we may be taking a break, but we'll catch you in the new year. So in the meantime, again, if anybody ever has any questions or topics that you would like us to cover, please feel free to reach out, email me, and I will share it with our task force, and we can put together a panel to discuss your topic. But until then, everyone have a great rest of your day, and we'll catch you next time.